So this is the 2004 AP Calculus AB FRQ question 5. It's asking the graph of the function f shown above consists of a timer circle and 3 line segments. Let g be the function given by g of x equals the integral of x to the negative 3, the function of t. So part A is asking to find g of 0 and g prime of 0. And to find g of 0, we have to look back at the given function of g of x. And to do so, we need to plug in, since we know what x is, we need to plug it in, which is going to be 0. And to find the function, so we have to look back at the graph, and we can see there's a trapezoid right here. So we have to find the area of the trapezoid, which is going to be 1/2 times the base, which is 3, times the height, and there's 2, so it'll be 2 plus 1, which you'll get 9/2. To find g prime of 0, you will have to look back at the original function f, the graph of f, and f of 0 over here is equal to 1. So for part B, it's asking find all values of x in the open interval -5 to 4 at which g attains a relative maximum. Justify your answer. So when looking for relative maximums, it's always going to be the second derivative. But since you have the original function, you'll have to look at a part where the graph shifts from a positive to a negative, and at this it is x equals 3, because over here we can see that it changes from positive to negative. Okay, so for part C, it says find the absolute minimum value of g on the closed interval of -5 to 4 and justify your answer. So if we're looking for absolute minimum, so for part C, it's asking find the absolute minimum value of g on the closed interval of -5 to 4, and it says justify your answer. So when looking for the absolute minimum, looking back at the graph, it's always where the graph changes from a negative to positive, and where that occurs is over here at -4. So x equals -4, and we have to use the candidates that are given, which is x equals -5 and x equals 4. So when we plug them into the graph, so g of -5, g of -4, and g of 4, we will get g of -5, which is equal to 0. G of -4, which we have to plug into the original function, which is you will get -1, and plugging it into 4, which you will have 9 over . And from all these candidates, the lowest value will be -4, so the absolute minimum value of g is -1. So now part D is asking find all values of x in the open interval of -5 to 4 at which the graph of g has a point of inflection. And the point of inflection is where the graph crosses the x-axis. And looking back at the graph, there are only 3 places where this happens. Here at -3, here at 1, and 2.